So last time we talked, you guys were in the process of finishing your prototype for your exhibition. How'd that go?
We're close to finishing it. We have hit a snag with 3D printing our inner reservoir. It's not worked on our prototyper so far. I'm just like halfway in the screen, but it didn't come out perfectly, so we're going to retry it again. Hopefully we'll be ready to go on Tuesday. We have talked to Professor Hughes, and it seems that 2 other groups are not done by our due date, so we don't know exactly when we're going to be showcasing the prototypes yet. I'm not pretty sure, so we're going to ask them that today after the conference. We're going to email you about it when we figure out the exact.
Did you figure out exactly what the deliverable was? Is it like functional prototype, or is it just something to look at? Are you guys doing it up there? Are you doing it at the first build?
Yeah, it's supposed to be a functional prototype.
We don't know whether it's going to be here or at first build. We have not discussed that yet, and he hasn't told us any details about it yet. So we asked him about this on our update with him on Monday, and he said he does not know what he wants to do yet. So he was going to get back to us this week later. Can you hear us okay, or do we need to
yeah, I can mostly hear you.
Okay.
Can you scoot just a little bit closer, because
That was right.
thanks. I've got impact wrenches in the background, so it's a lot harder for me to hear.
Right. Okay.
So has all the work since we last spoke been dedicated towards getting that prototype working? Then has that been where all your focus has been?
Yes.
Yeah, it's pretty much. Yeah.
Have you hit any major snags other than the 3D printing?
No other major snags.
No,
we have what? This is only part of the
Yeah, we got the top screw printed off right here, but the big reservoir is going to be about this big, and it's going to sit inside of the metal casing we've already had made, and it's going to contain all the water, and it's just going to drain out into the heating element. So
we're going to go through a similar design as what the one from Purchase uses, because it seemed to be the best process to give us the most continuous flow.
At the same time, we don't have to heat up a huge reservoir of water to boil anything.
Yeah, we didn't want to. Yeah, we didn't want to have to heat up almost a gallon of water at a time, because that would take a lot more time. So their design works where a small portion of the water that was in the main reservoir drained to a heating reservoir that would then heat up just that small portion of water to create steam. Once the steam rise out of the hose, then it would create more room for more water to come out. Create more
steam. Guys, you're breaking up a little bit. It's probably your internet connection, because I see Mary just fine. So. But what it sounded like you were explaining was what you guys talked through last week, which was kind of change your design concept based on taking apart the unit that you bought to go from the big reservoir to like a smaller heating tank, right?
Yeah.
Yes. Sure. And that's what we're 3D printing right now, is the reservoir for that design. And we have the file parts that we're uploading to the First Build website too, for what we've done. We're getting all that uploaded. Did we already do it?
Yeah, we already.
We already uploaded the parts that we are printing off right now. So everything has been uploaded. Everything's been put on the First Build website. So that's good to go. Today was we just found out that it didn't print because it's an overnight print. It's going to take several hours to do. We found out when we came in today it didn't work. So we're going to have to retry. But we're going to get the rest of the casing finished today. And it's not going to look the prettiest, but we're going for functionality over anything else right now to make sure that it functions, and then we'll work on how it looks after we get a functioning prototype.
Okay, if you guys fail again with the print up there, I would suggest if you get back in touch with Mary and see if maybe they might be able to print it for you down at First Build. If it's a problem with your printer, they may have better luck down at First Build. If it's a problem with the file, then it's not going to matter where you try and print it. So
It's a problem with how big it is, how big the part is. So it gets partially the way done, and then it messes up with one layer, and then it gets caught, and then moves around on the maybe on the part file, and so it just pushes it around and makes it a blob.
Just a ball of plastic at a nozzle in there.
So one thing that you can do if you're having size issues is break it into puzzle pieces.
Okay.
Because really a 3D printer works just by melting it. So you can melt it again to stick it back together.
Yeah, that's one thing we were thinking about, but we wanted to see first if we can make it all one piece before that, because we figured that it might take less time to do that, and it would probably be more sharply sound rather than usual.
About water leaking out, that was a big concern.
you can make a pretty watertight joint with what we would call a solvent weld. You can basically take like MEK and basically just solvent weld the two halves of it together. We do that here all the time with prototype parts, actually.
Okay.
Okay.
Yeah, we'll definitely try that. This will probably work better for us.
Another thing that will work pretty well, as silly as it sounds, is if you go to like just like a local hobby shop and just grab like model cement, basically the cement you use to put the little model cars or model airplanes together, that works the same way. That's a solvent. That's basically a solvent that dissolves the two pieces of plastic and fuse them together. PVC cement will do a similar thing if you buy like not the PVC specific cement, but the multi-purpose plumbing cement that's designed to do PVC and ABS. If you go to like Lowe's or Home Depot and ask, they'll show it to you. But that'll do a similar thing. That will solvent weld two halves of plastic together.
All right. So that's our goal for the rest of this week, is just to finish it up. And hopefully by Monday we'll be ready to showcase it. But not guaranteeing anything yet, though. He told us that dates for prototype do are can be moved depending on where we're at. So hopefully we'll be ready to go. Nothing now besides just the final way.
Just don't let the 3D printing hold you up too long. I mean, it's one of those, it's one of those, without sounding too harsh, it's one of those, the definition of stupidity is trying the same thing over and over again things. So if it keeps failing, don't let it hold you up too much. Either break it in half, try something different, call Mary, see if they can print it in one of the bigger printers down at First Build. Don't let something like that stall your progress completely.
Okay. Yeah.
Right.
And then while you're waiting on that to print, were you guys able to, again, I apologize, I haven't had a chance to go look at the project. Were you able to upload some of the supporting documentation that we talked about, where the baselining, the competition for, first time to first steam and total steam time?
We uploaded all that on the Facebook website through the project update.
Did you just upload it today? Because I was looking yesterday and I had some questions about a lot of what you uploaded.
No, we uploaded some of it last week.
Last week? Okay, yeah. So, here we go.
I'm going to pull it up too.
Yeah, they have it.
See if I can find it.
Yeah, so you guys had a graph that I was really curious about.
Okay, so,
I don't know. I gave you guys that. I don't know what exactly.
oh, what? Well, explain this what the graph is, just so you have a...
Hold on, I'm just going to share my screen.
Okay.
We can all look at it at the same time. I know, it's like Inception. All of a sudden it gets crazy. You're looking at yourself so many times. I'll make the screen a little bit bigger before I switch tabs. Okay, here. So this is kind of what I was looking at, and I was trying to understand your graph, and really came down to I couldn't. So what I'd really like for you guys to do is, one, go in and explain it for the world, not just for PJ and I right now. But what is this graph? Like, what is here, and what are your calculations of volume at the top?
Okay, do you want us to, like, in the comment section explain it, or edit it?
Yeah. If you can type it out, You can do a video of somebody pointing and talking through it. I don't really care how you do it. This just needs a lot of explanation because there's numbers here and I don't know what they mean or what you're getting at or what is this showing me.
Alright, well, you want to go ahead and explain to her what we would do? It's the graph showing
Yeah,
steam.
it
and how
was on the left-hand side, the left axis, the one going in the y direction. That one is amount of water needed for that amount of time. It's just really small.
Is that in cubic meters?
It's in milliliters.
That's in
No,
milliliters.
no.
It's in milliliters, and then the x-axis is time. So
Or what?
Time of continuous steam.
yeah, time of continuous steam.
So it's a plot, a graph showing the amount of water and how much that amount of water gives you in continuous steam. And we plotted that graph to show how much in milliliters you need for each minute of continuous steam.
Okay, the other thing I was confused about is you call this graph time of steam versus volume of water, and then it also says advertises versus actual time of steam. So it sounds like you're plotting two different sets of data, but I only see one set of data on here.
We're getting two different sets of data from this graph. We're getting how much volume we need for our reservoir, and we're also saying that advertised steam versus actual time was not actually the same from the steamer that we got. Am I saying that right?
Yeah. So in the orange below,
Mm-hmm.
we had that was what's written there is what the advertised on the box said, and then above it is the actual data point that we got for that data. So
Okay.
the name probably needs to be changed for that, but that was our trial versus our actual test, and we tried it. I tried it myself again, and it corresponded to the line on the graph again. I guess I need to put that point on there again for there, but we tried more than 4, and the graph holds up for that.
When this happens, because sometimes people's faces are not ideal for the
You're cutting out, Mary.
You're cutting out, Mary. We can't hear you. David.
Do this last week. They were trying to do it in their lab, and it was pretty funny. Tour came by right in the middle as well.
Yeah, we're losing internet connection.
We're losing internet connection, so y'all are.
That happened tonight, so I came in at noon, so thankfully I'm not assigned an area because my full afternoon is nothing but capstones.
Are you guys back?
Yeah, that
Yeah.
it's cutting in and out.
Okay.
So you
It's
guys,
frozen, but we can hear you.
it sounds like you know what the graph is, but so one of the things that we talked about, I don't remember if it was last meeting or the meeting before that, was basically anytime that you conduct an experiment like that, making sure that all the conditions of the experiment and exactly what the procedure was is documented so that somebody else could go recreate your experiment. So I think this is one of those situations, and it's not unique to you guys. We run into it all the time here too, where somebody collected very relevant data, but unless you were sitting right there to explain it, it wouldn't be relevant to anybody. So I guess the feedback would be let's document that graph in such a way that anybody could click on it and walk up to it and know what they were looking at.
Yeah, that's one of the reasons why I wanted to pop into this particular meeting is because I'm not part of you guys' project all the time, but I still should be able to pop in and see what it is you guys are doing and understand what's going on.
Okay. I had a suggestion on the graph. Would it make it easier to read? Because pretty much what we're getting at is the advertised time, which we talked about this in our first meeting. Our advertised time that it said that if you continue steam per amount of water you have, was not the same as our tested time that we used. So should we have like one line on the line graph that shows the advertised time and the other line that shows what our tested time showed, so that you can just make computer.
I would much rather see it represented that way in like a different color line or added or some other way to recognize it.
Okay.
The percentages that are underneath your times, also you need to clarify what those are, because I don't know what's that percentage of. Is that volume or?
It was a percent difference, I believe.
Yeah.
It was a percent difference between the actual time and the advertised time.
Okay.
So I figured that out because I knew what you guys did, but without somebody knowing what you did.
I was
The
guessing.
other thing that's missing from that comment, guys, is you guys remember the reason that Sylvia and I asked you to do a test like that to begin with? It was essentially to develop a spec for your own device. So we talked last week, the biggest thing that came out of that was you guys ended up with a target for saying you didn't want your time to initial steam to be any worse than that unit. And you set a goal for what you wanted your continuous steam delivery time to be. So you guys essentially were able to baseline a competitor and come up with a spec for your own product. And I don't see that, and maybe I just missed it, but I don't see anywhere in the posts right now on the project where you specifically gone and said, hey, we want to make sure our time to first available steam is less than 40 seconds, and we want to make sure we have at least half an hour of steam.
Okay, we can put some up. Definitely.
Because we have the time that it took. There's actually two different times. What was it? It was from cold start.
Cold start was about 42 to 45 seconds, and then after that, once
After
the
heating,
heating element was actually warm, it was like, I think, 11 seconds to steam.
So you've got two specs that you want to be able to right?
Yeah, exactly. So we have those, so we can put those on there. I think we also did.
Yeah, and I know we've made the suggestion before, but my suggestion would be to actually come up with a document that is the specification for your steamer. It doesn't have to be complicated. It just lists the 5 things that you absolutely want to be able to accomplish. What is your cold steam delivery time, warm steam delivery time, total steam delivery time, has to attach to the dryer without damaging the dryer. I'm trying to think of the other ones that we've talked about, but I shouldn't have to think of those, right? There should be a list of that someplace where I can just go see these are the key deliverables.
Yeah, we can come up with that. Because we've been thinking about them the whole time. We just haven't actually put them in a list in the document and put them on the so.
Unfortunately, documentation is one of the most important things of what we do. It's the most boring, but it's got to be done so everybody can understand what goes on. Nobody likes it, so you're not alone. But it's important so that people like me can see your project. They're like, oh yeah, that's cool. And then I can tell this great story about how you guys arrived to this really cool feature.
Yeah.
All right. You guys are doing well.
Thank you.
So other than the 3D printing, is there anything else that's causing you guys any sort of issues that we can help with?
Not really. We've taken apart the steamer, put it back together, tested to make sure it worked. Everything works again properly. We got enough space inside where we don't need to make a new outer casing, so we're good on that. We have a connection for the hose to connect to the metal box, which works, so we don't have to worry about that either. And we have mountings inside of the metal casing that's going to be made out of foam that we have here that's heat resistant, so we don't have to worry about that either. So right now we're just waiting on that inner reservoir so we can put it in there, seal the top on, and be done. So.
Okay. Well, if anything else comes up, just make sure that you guys email us. And like I said, if the 3D printing continues to be a problem, there's people that we can talk to. I'm by no means an expert, but we'll find somebody who is that can help you, make sure you get printed what you need printed.
We're going to rip it apart. After we get out of this conference call, we're going to chop it into pieces and try that method.
I haven't talked to them about this yet, but I had another suggestion that may or may not work. But we have, plenty of acrylic in our lab, and we have acrylic solvent like you were talking about too. So we used in our summer class to glue, to melt the acrylic together. and it'd be much quicker and simpler than 3D printing something. Would that be a possibility to just use the acrylic in that way? I mean, it would still be a watertight seal after we melted it.
Do you
As
remember
long
how?
as it's representative.
What is
Sorry,
Go ahead, Mary.
I don't remember at what temperature acrylic starts kind of deforming a little bit. I don't know that it handles heat very well.
Well, that's the beauty of what we have with our heating element. It does not heat the outside air around it very much.
Okay.
You can touch the casing and not burn yourself.
It's still warm.
It's still warm, but it's nowhere near above 100 degrees.
Plus, let me make sure you have our concept. The thing that is going to be heating the water is only going to be a small portion of it. Our main container isn't going to be where the water is going to be heated at, so it's going to be away. It's not going to be, the heating element won't be inside the acrylic container if we decide to make that acrylic. So it won't be. It'll have it'll contain all the water, and then we'll have a hose that goes and runs the water that's been heated to a smaller heating chamber that will heat a small portion of the water. So it won't be that close to where all the heat's going to be.
I have drawings of this. I just haven't had a chance to upload them yet.
I would love to see a cross section and an exploded view of your whole system. Because I'm trying to understand what you're describing, and right now I can't really picture it. But if I could look at a cross section and an exploded picture, I could get it.
Okay.
Okay, we can do that.
Yeah, we can do that. We'll make sure you get those so that you can better understand our concept, because it's kind of hard to explain in words. So.
And
Pictures.
just add them to the project, guys. I know you've got it because you guys held it up in front of the screen last week, so it exists. Let's just get it up on the project. And then, an explanation, like that's a really good example of, the reason you guys did that was so that you didn't have to heat up an entire gallon of water before you got the first bit of steam. So that's a really good example of how your spec flowed down into a design requirement, right? You decided to go with a smaller two chamber approach so you could get steam in 40 seconds. And go ahead and explain that on the posting when you put it up.
It's important. That would be a big selling feature.
All right.
Okay.
Well, that sounds good.
Okay, so it sounds good, guys. You guys are doing well, and you're on the right track. And if there's let us know, and then do keep us up to speed on where your showcase is going to be. Because, like I said, if it's going to end up being at First Build, Sylvia and I will come down and make sure we're there for that.
Okay.
Also, for your acrylic box, if you want to go that route, I think PJ was trying to get to as long as it's representative of what you're trying to do, that's fine.
Okay. Yeah. All right. Well, that's awesome.
Just make sure it's going to function the same way.
Yeah, it should still have the same function if you decide to go that route. Now, I'm not saying we're going to, because I haven't even talked to them about it, but it's just an idea I had. So.
It's not a bad.
No, it's good.
I like it a lot better than
Yeah. I like that you guys have a plan B, because that's actually one of the most important things is you don't always know that plan A is going to work. So having a backup plan is something that you should always be ready for.
Okay. All right.
Thanks, guys. Well, here, say hi to Sylvia.
Hey guys,
Yeah.
shall we have another session next week, or do you think it's going to be earlier than that we will meet?
So you want to have another session Monday? Or?
Monday sounds fine.
Monday works for us if that's okay with you all.
Monday? Okay.
Do you have a preference, morning or afternoon?
Yeah.
I prefer afternoons. I'm working all morning.
Yeah, he's working. So, is this time okay, or do you need it to be a little bit later in our class?
Yeah, let us look and see what our calendars look like, but we'll shoot for Monday afternoon, sometime as close to 1 as we can get, okay?
Works. Just email me and I'll relay it back to them.
Okay.
Perfect.
Thanks, gentlemen. Bye-bye.
Bye.
Bye, Mary.
Bye.